couple of them yesterday, but give me some ones that we didn't mark that you need me to do. 6. We'll start with 6 then. All right, find cosine y and tangent y if cosecant y equals negative square root of 6 over 2.
And
What? Oh, sorry. Thank you, Noah. And cotangent y is greater than 0.
yeah.
Thank you. Noah's not going to let me mess this up. So cotangent is positive is what that's saying. All right, so what I need to do is I need to rewrite cosecant some way where it relates to either cosine and or tangent so that I can find those values. So I'm going to go to my identities over here, maybe my reciprocal identities, maybe my quotient identities. It looks like that's probably all that I will. Does it? Oh, I didn't read the directions. Thank you. Okay, well, if I use Pythagorean identity, so what's the only Pythagorean identity that relates cosecant? Cotangent squared plus 1 equals cosecant squared. Yeah, well, you got to use that, yeah. All right, so I'm going to plug that in. I'm going to say cotangent squared plus 1 equals, I know what cosecant is, right? And so this is negative square root of 6 over 2 squared, right? Everybody at least start there? All right, so if I square here, I get cotangent squared theta plus 1 equals 6 over 4. I'm just going to change to 3/2. I'm going to subtract 1. What's 3/2 minus 1? 1/2. What now? Square root, which gives me, that tells me that cotangent theta is 1 over the square root of 2, or square root of 2 over 2. Yes? If I just square rooted and rationalized the bottom. Now, if it had said in the beginning that cotangent was less than 0, then this would be negative root 2 over 2. Because whenever I take a square root, it can be positive or negative, right? Right. If it said in the beginning, it said cotangent's bigger than 0. If it had said less than 0, then I would have taken the negative square root there. Now that's cotangent, and it asked me to find tangent and cosine. So tangent here, yeah, just flip it. That's exactly right. It's just square root of 2. No, that's tangent. It said find cosine and tangent.
The first one is
Cotangent. Right? Are y'all following me? You see what I'm saying?
Find cosine.
No, where's it? Oh, yeah, I haven't gotten there yet. I'm finding one thing at a time. Yes, I have to find cosine, but right now, the first thing I did was I found an identity. It told me to use Pythagorean identity, and I found one that would relate what I was given to one of these in some way. Well, cosecant squared, there's only one with cosecant squared in it, and it's got cotangent, and I know the relationship between cotangent and tangent. They're just splits of each other, right? So I plugged in what I knew, and I solved for cotangent. Because if I can find cotangent, then I can find tangent. I just flip it. Still okay? Cosine. So how am I going to find cosine now? How are you going to find sine? That's what I would do also. I would go back. So now look at what I've been given. Now I have a value here, and I have a value here, right? So maybe now I go into the tan squared plus 1 equals secant squared theta. because I'm looking for cosine, and this is just the flip of cosine, right? So I'm going to plug in what I know. I'm going to take this. So I got the square root of 2 squared plus 1. Squared and square root cancel.
Oh.
It's 2 plus 1, which is 3. But this is secant squared. That's still not what they asked me to find. I found tangent. That's good, but they asked me to find cosine. So let's go ahead and solve this for secant by doing what? Square root, right? Square root, square root. Then you just have to flip it like last time. So if secant is square root of 3, that means cosine is 1 over square root of 3 They are hard. All right, Addie, I think you said 4. Okay. Okay, 7. I heard 7 too. Let me go in order. All right, 7. I feel like I did 7. Did I not? There was another beta one. All right, that's what I'm finding. If I know that secant of beta is 3 over 2 and tangent of beta, did it say use Pythagorean again on this one? Okay. So I've only got 3 Pythagorean ones, so look at what I've been given. Which one should I probably use? Yep. Tan squared plus 1 equals secant squared. Plug in what you know. So tan squared plus 1 you sure? I got 9 over 4. Did you say how do you subtract 1? Or you got it? So if I subtract 1 from both sides, I would make it 4 over 4. So tan squared beta would be 5/4. And now square root. Okay. Common denominators subtract. Square root. Liza, you look sad. Are you okay? Okay. I hope the identities are not making y'all sad. I'm so sorry. Square root of 5 over 2. Yes. Well, we were running short on time last semester. I threw them the identities, and then they had to do a project with it. I don't think you want to do that project. There were tears with that project, and that's why I said I'm just gonna sit here and. They also had, I think they had like a 50-point quiz and a 50-point project. But the project it was a disaster. It was hard. It's hard. It's really hard. The magic cube. Okay, so yes, we're going to do the negative. Why, Laney? It's right. It tells us to do the negative. So when I take the square root, I'm taking the negative root. Uh-huh.
And now we have to find.
When you take the square root, because square root is plus or minus, right? Okay, so now we have to find, Noah's keeping us on track here. Now we have to find cosecant.
So you flip.
You could.
Put it in.
Well, let's see what we need, right? We've got, look at the ones that you have and look at what you need. You need cosecant, right? So I need cosecant. I have tangent and secant. You could, yes, yes. And that's probably what I would do. That last Pythagorean identity is cotangent squared plus 1 equals cosecant squared. Well, by having tangent, I also have cotangent. In other words, if I flip this over, if this is tangent, then cotangent is 2 over square root of 5. No, it's still negative, right? But when I square it, and I'm not even rationalizing the denominator here because I'm getting ready to square it. Just because what happens when you square a radical, it cancels and goes away. So this ends up being 4 over 5 plus 1 equals cosecant squared base, which is 9 over 5. And now, you're right, now I can square root. And then just rationalize that bottom. So you got to think about where is secant less than 0, so where is secant negative? So on my unit circle, secant is 1 over cosine, right? So where is cosine negative? Cosine's negative here, right? So that means this is where secant is negative. So I'm on that side of the circle. So as I'm solving, yeah. What else? All right. 9 says to use the cofunction and even odd identities to find each function value. So let's go through them. So number 9 says the tangent of negative y equals 0.9. And it says find the cotangent of y minus pi over 2. So I'm going to go over here to my cofunction identities, right? And my even odd identities. Now, first of all, I'm going to use the even odd first. If I've got the tangent of a negative value, what happens? What does that really mean? So the tangent of y is going to be what? Is it 0.9 or negative 0.9? Negative 0.9. That's that even odd identity. Okay, that's the first thing that I would do there. Now, cotangent of y minus pi over 2. So I'm looking at my, okay. Okay, so y is your variable here, but look at the way you have cotangent pi over 2 minus y, right? Y'all agree with that?
Oh.
So that's what the identity is. The identity is this equals tangent theta, right? Isn't that the identity? But this is what I've been given. The pi over 2 is negative, the y is positive. The signs have changed. So this is really like saying cotangent of negative 1 times pi over 2 minus y. Because all the signs changed, right? Did you see that? I've taken out a negative. That's all I did. Now look at cotangent negative theta. What's the cotangent of negative theta? Look at your even odd. Look at this one. Cotangent of negative theta is negative cotangent theta. It's just like the tangent one here, right? So I could rewrite this as negative cotangent pi over 2 minus y. I'm trying to get it to look like one of those identities without changing its value. Okay. This is the identity. Do you agree? Oh, no, not that one. Up here at the top. Sorry. This is the identity. This is an identity. Yes? All right. It looks dangerously close to what I'm being asked to find. The difference is all the signs are switched. Yes? So I factored a negative 1 out. Okay? So if I asked you what is the cotangent of, if this is a negative in front of here, well, that just tells me I can drop this negative and put it out front. So that my identity, I can see my identity in what I have. I'm just trying to rewrite it to look like an identity. So now what do I do, right? The cotangent of this, ignoring that negative right now, is tangent theta. Do you agree? So this is really now, just follow that negative down. So this will be negative tangent of, and I'm mixing up my thetas and my y's here. This is really y. This is just negative tangent y. Well, I know what tangent y is. What's tangent y? Yeah. Yep. Tangent y is negative 0.9, which means that this is going to simplify down to 0.9. Yeah. That's your answer. Yeah. Do what? Not all the time. I'm trying. Let's look at 10. Let's look at 10. This says that the sine of pi over 2 minus theta equals 0.34, and it says find the cosine of negative theta. All right, sine of pi over 2 minus theta. This one's a little bit easier because it's written exactly the way it's supposed to be, right? The sine of pi over 2 minus theta is what? Cosine theta, right? This equals cosine theta. Agree? That's the identity there. Look at cosine. Yep. The second one on the left under cofunction identity. Oh, you don't have the same type I do. Cofunction identities. It should be the 1, 2, 3, 4th one. Yes. No, it's positive. It's positive. Cosine of negative theta is the same thing as cosine theta. So they asked me to find cosine negative theta, so it's just going to be 0.34. It doesn't change the sign here, because cosine negative theta equals cosine theta. All right, 11 I'm going to have to switch also. Do you see why? Do you see how it's different? So I got to take that negative out, right? So here we go. It says find cosecant x, okay? I need this to look this way so that I can match it up to my identity, right? So secant of pi over 2 minus x is equal to cosecant x, right? And that's what I'm trying to find. So to switch all the signs in here, I have to pull out a negative 1. So this is actually, because the way the identity reads, the pi over 2 needs to be positive and the x needs to be negative. And they're backwards right now. Now what happens to the secant of negative theta? What's secant negative theta? It's just secant theta, right? It doesn't matter. It doesn't matter if the theta is negative. It's going to drop off and leave me with the same thing. So this is the same thing as the secant of pi over 2 minus x, because that negative doesn't impact. Are you cold? And the secant of pi over 2 minus x is cosecant theta. Oh. Is this 9? Cotangent of negative because of this identity. If it's negative inside, then it makes it negative on the outside. They're different, yes. So this one, yes. So cosecant theta is going to be exactly what I started with, which was negative 1.06. Well, it's not easy. I understand it. It's not easy. It's not. For some reason, they are just, now maybe they're easy to some people, but I don't think they're easy. Say again? Yes. So cotangent of negative theta. Yeah. That's all you do. Well, for this one, you didn't have to take out a -1 because it was already just like the identity, right? The identity says that tangent of pi over 2 minus alpha equals cotangent alpha. It's asking for cosecant and cosine. If secant is negative, that means cosine's negative. So that's really what they're telling you. We're going to keep practicing with this some. I'll have you some practice tomorrow too. Well, if y'all are here, we're here. But right now I want to show you some simplifying tricks, which is, we're kind of doing the same thing. We're still working with these trig functions. And the more we do with this, the more familiar you'll get with these identities, and they'll start popping out to you a little bit more. Heck no. Oh, you can graph them. You do not want to graph these. No, you do not want to graph these. All right, let's simplify some. Oh, boy. Now, the goal when we simplify, I think these are a little bit easier than what we were doing just now, but we're not finding function values, we're just simplifying. The goal here, remember how whenever we condensed logs, whenever we got down to just one log, we were done? For this, when we get down to just one trig function, sine, cosine, tangent, cosecant, secant, or cotangent, just one and whatever else follows it, then we're done. Okay? But we're trying to simplify down to just one and only one trig function. So a single trig function. We will use identities to help. We'll give you a couple helpful hints before we jump right in of strategies you can use to help you as you do this, because sometimes you look at it and you just go, oh my gosh, I just don't know. And so here are some things you can do to kind of help you along. We'll call it tips and tricks. Not necessarily in this order, it's just things that you can look for. First thing is, can you rewrite using either reciprocal or quotient identity? In other words, if you have a cosecant, can you change it to 1 over sine? Will that help you? If you have a cotangent, is 1 over tangent helpful? Is any of that helpful in your simplification process? Always look for, especially if you have a squared somewhere, but not only squares. Look for a Pythagorean identity, or try to create one. And as dumb as it sounds, if you see a 1 in the problem, you could replace that with sine squared, cosine squared, and it might help you eliminate something. It might help something cancel out, cross out, or anything like that. Third's going to be y'all's favorite. Try to combine fractions. Remember, addition or subtraction requires common denominator. I know you do, Miguel. You love it. Two more little tips. Again, this is why what makes this difficult, I think, is because I can't just say do this every time, because this is all about working with what you got to try to get it down to a simple trig function. If you can't combine fractions, maybe you can break fractions apart. And you may even be able to factor something. Maybe you can factor out a sine x. Maybe you can factor something along those lines. But yes, you may be able to factor. All right, and you need a break? Okay, yeah. You'll like this one better. Simplify. Remember what simplify means? Single trig function. Ideas on what I might be able to do first. Okay, make the secant one into cosine. Now what? Times. I will tell you, I always find it helpful whenever I get stuck to go as basic as possible. In other words, if I can write everything in sines and cosines, I do. To try to eliminate some stuff. That was a hint for that one. Turn tan into what? Sine over cosine. Okay. So if I've got 1 over cosine minus sine theta, and I'm changing tangent to sine over cosine. What does that give me? This becomes what? Sine squared over cosine. And what do you suddenly notice? They have a common denominator. I don't know if it's going to help me or not, but maybe I'll combine them and see. But you can do Pythagorean. Remember that Pythagorean identity that says sine squared plus cosine squared is 1? Well, if sine squared plus cosine squared is 1, what's 1 minus sine squared? Or you can replace sine squared with cosine squared. It is, right? If I solve this here, if I move the sine squared over, I get 1 minus sine squared. So would you all agree that 1 minus sine squared is the same thing as cosine squared? There's 2 cosines up top, 1 in the bottom, which means it just simplifies just to cosine. Okay, so maybe you didn't see, I feel like I lost y'all on the Pythagorean part. I don't think it will be once you start working with them. Just reduce down to cosine. It is. I agree. Secant's 1 over cosine. Yeah, cosine's not even in there initially. There's a 1 over here. There's a 1. Let's do another. So, anytime you see a squared, check to see if you can use some type of Pythagorean identity, right? And I know that sine squared plus cosine squared is 1. Well, if sine squared plus cosine squared is 1, then I have to say that cosine squared is 1 minus, or I could say sine squared is 1 minus cosine squared. I can use that any way that's beneficial to me. You see what I'm saying? No. Tomorrow. No, I'm just kidding. It's not a lost cause.
I do not like those cows. It's not like those cows.
That went the whole other direction, Miguel. Okay. All the girls were like, oh, we can't have that. All right, simplify. You can if you want to. You think? That's your guess? It's just tan. Noah's vote is tan. Liza says cosecant. Whoa. I don't even know what I just wrote. Noah says tan. Liza, what'd you say? Cosecant. Kenzie says secant. Who said cotangent?
I'm not gonna cook it.
Laney and Emery can't change it now, buddy.
I'm going to
Cotangent. All of the above. All right, let's see who's right. Just looking at it. Absolutely. That's always my go-to here. Yours too? See, Kate, I knew we were soul sisters. What? I just saw it whenever I did that.
Oh, actually, tan and cosine.
You're what? Oh. Okay, yes, Miguel, yes, you are correct. The cosines cancel each other out. Because they're both in top.
Nobody was right.
That's it. That's it. Is it 1? Is it 1? Oh, it's just like theta. Let's do some from the homework. We're going to do several of them together, yes. I'm going to start with number 6 because it looks the worst. Yeah, put one down for her. I didn't know.
Yeah, what are we doing? I'm just gonna sit. All, not even just this class, all day long. I'm just
Oh, Noah.
living on breathing earth and
It's a doozy. It is a doozy.
I know what you can do with this one. I know what you can do with this one. Both hands can come from the cosine, and both secants can come one over cosine.
And how's that going to help you?
You can now just add them together. Just sine over cosine.
You could do that. I probably would not go that route, but you definitely can do that.
Something else you can do is
I would FOIL them out if I were doing that. And let me show, the reason is because one's a plus and one's a minus. So I should, if I were, now that's not saying this way's right, y'all. There's not a right or a wrong way to do it. Miguel is actually, if you understand that way better, that would work also. He's talking about making this cosine over sine and this 1 over cosine, sine over cosine, so that they have common denominators. You can combine them and then multiply them. That works. You think that's easier than multiplying? Okay. So change this to, we'll do it y'all's way. Okay, he's saying change this to sine over cosine. Change this to 1 over cosine. Same thing over here, sine over cosine. This one to 1 over cosine. Now they both have common denominators, right? Say right, because they do. Thank you. Okay, so if they have common denominators, I can combine the top, so that would be, sine beta plus 1 over cosine beta times sine beta minus 1 over cosine beta. I was going to FOIL. Y'all said that would be easier. Well, Kenzie and Miguel said this will be easy. Okay, if you FOIL, keep FOILing. I'll FOIL over here as well. Oh. You're still going to end up having to FOIL. No, don't apologize. Now, you might not see this right off, but I see this right off. Just because I notice these denominators before I even start FOILing, right? Yes, when you FOIL it out, yes. Let me keep going that one. One of them. That's what's on the bottom. That's always been on the bottom.
Oh.
All right, so if you FOIL these out, I got sine squared beta minus sine beta plus sine beta cancel each other out. Minus 1, that should look familiar to you, or close to it. Over cosine squared beta, everything over secant beta. Yeah, right here again is that Pythagorean identity. Remember, sine squared plus cosine squared is 1. This one you will use more than any other one, or I do. Which means sine squared is 1 minus cosine squared. Cosine squared is 1 minus sine squared. Uh-oh, that one's not Pythagorean. I absolutely would. I would do that. I would turn the secant into 1 over cosine. Now, when you do that, it is. Instead of dividing by a fraction, I can just flip it. So I'm going to do sine squared minus 1 over cosine squared. and I'm going to multiply by, instead of dividing by 1 over cosine, I'm going to multiply by cosine. And so I have 1 up top, 2 in the bottom. Still not down.
Make it negative.
When we foiled.
Make it negative.
Huh? We're fixing to. Miguel's right. Yeah. All right, so Miguel is saying making it negative. Do you understand why he's saying make it negative? Well, there was a little bit quicker way to get to it than what we went to, but it's okay. Because sine squared beta minus 1 is not 1, but negative sine squared plus 1, right? All the signs are changed. You see that? Remember how we were factored out a negative 1 before? All right. So this is like before where we took out a negative 1. I could put negative 1 times this, and that would make my sign negative. That would make my 1 positive, which suddenly does look like my Pythagorean identity. It still equals c squared. I was just saying that, yeah. What are y'all talking? Let me see your hands. No, I'm just kidding. That's right. That's right. I took out a negative 1. Did you see that I recognize that being really close to this Pythagorean theorem, this Pythagorean identity, right? Anytime you see a 1 and a sine squared or a 1 and a cosine squared, automatically be thinking about that Pythagorean identity. Or maybe it would be helpful for you to change. What if I change sine squared just to 1 minus cosine squared? Maybe that'll help you see it. So this is 1 minus cosine squared. Yes.
What's the next step? What's the next step after that?
That's way easier. Okay. Do it like that, then just change sine squared to 1 minus cosine squared. So, right, if sine squared is now 1 minus cosine squared, 1 minus 1 cancels out. I've got negative cosine squared over cosine. And now you breathe a sigh of relief because negative cosine beta is my answer. If you did it this way, is that what you're talking about? This way? Because this one and this one canceled out. Yeah. No. I changed sine squared to 1 minus cosine squared, but that minus 1 was still there. Shall we try another? Number 1. I would start number 1 by changing tangent to sines and cosines. That's always my go-to if I don't know what else to do. Now the other thing that you could do, that's okay, then it would be sine squared over cosine squared. The other thing you can do is go ahead and find a common denominator and make these just one fraction and see what happens. Oh, sine over cosine. So tangent could become sine squared over cosine squared. And so then I think, okay, instead of dividing by a fraction, I'm going to multiply by its reciprocal, right? So I've got sine squared times, and I'm going to flip this over. Yeah, they are. What? Oh. No. What? What are you saying, Kinsey? Bye-bye signs. Or replace the cosine squared with 1 minus sine squared, whatever, however you see it better. But this is, yes.
1 minus cosine squared x is sine squared.
Yes.
We done for the day.
Pick another one.
Not even looking for you.
You know they start out easy. 12?
Yeah.
Oh no. Oh no. Number 2. Tangent sine over sine.
That's where I always start. Okay.
Okay. Let's throw it out.
He's just being funny, Kinsey. He's not trying to be mean to you. He didn't say he was sorry. He just said he wasn't being mean. All right, what happened? Bye-bye one of the cosines. Frick. What the frick? I know. I was scared where you were going with that one. All right, I got sine squared over cosine. Yeah. No, she wasn't. At you? But just still.
Don't have to do that line.
Okay. What y'all fixing to cancel?
You put everything over 1.
I think that I'm going to multiply, get it a single fraction instead of a complex fraction. So top times flip the bottom. Okay. I don't know. This might not help, but it might. Kinsey doesn't need any justice.
It's easy. They're not like a right or a wrong way to write.
No. You can do another variable if you like. Oh, they're just not there. Am I getting anywhere with it?
So why can you not?
I'm going to split this fraction. Nope, that's not going to do me any good. Psych. I'm not stuck yet. Trust. What did I start with? I can figure it out. Will that do anything though? No, you can't do that. The humdinger for sure. I think we started out wrong on this one. I know.
If you started it off wrong, I'm not.
All these different like symbols and whatever they mean, Greek, ancient, whatever they are,
Ancient.
jumping around the